Are you guys ready? Yeah! Okay. So we're going to talk today about what makes our weather. So you guys are older. So the last couple of weeks I've been with second graders, so we've gone really basic. We're going to take it a little step up today. Probably some things you learned already in the second, third, fourth, and maybe already fifth grade, but we're going to try to go over it a different way. So first of all, our weather's changing. We went from hot to rain and cool. So we're kind of in between right now. It's gorgeous right now today. We're in the 70s this afternoon. It's beautiful, but of course it was a brutally hot summer. This morning was a little chilly. We had rain last week, and we've got more rain on the way next week. But all of our weather starts with the sun. If we didn't have the sun, we wouldn't have any kind of weather. But that's the number one thing we need for our weather. That drives everything that happens for us. The sun is 100 times bigger than the earth. The sun is 93 million miles away from us. It takes 8 minutes and 20 seconds for the light from the sun to reach us, which means we're walking always around in old light. When you see a sunset, when you see that final little piece of sun go down, did you know that that light from the sun has already been gone for 8 minutes and 20 seconds? That's how long it takes the light from the sun to get here. So we're always walking around in old light. We, of course, get heat from the sun. It comes through us called the process of electromagnetic radiation. Let me show you what electromagnetic radiation is. Can everybody see this right here? Everybody see that? Is it doing anything? No. I'm going to put some heat on this. So this is going to represent the sun. It's going to represent electromagnetic radiation. When I put heat on this, what's starting to happen? It's moving. It's spinning. Did it spin? Did the lights make it spin? No. Did the room temperature make it spin? No. It was completely still. But when you put heat in the form of electromagnetic radiation is the heat, it now spins. If this was hotter, this flashlight, it would spin even faster. But that is electromagnetic radiation. You can't see it. Make sure I turn this off. The warmth you feel right now, or when you go outside, you can't see. But you can feel, but you can't see it. That's electromagnetic radiation. So atoms carry heat particles all around us. That's what warms us up. So heat energy is created, and this is called a radiometer. But that's what's happening. So you can't see these microscopic atoms that are all around us, but when they come in from the sun, they warm us up. And when you have a device like this, it shows you how electromagnetic radiation works. There's also visible light from the sun. So that's how we're able to see. He has a black shirt on and yellow shorts. You have a red shirt on and blue pants. We're able to see because of the visible light. This, for example, is the sun. We got the sun, obviously, and then you have a halo around the sun. So this is visible light. Where we live and looking up to the sky, as far as we can go, this is called the troposphere. That's as far as our eyes can see. That's where all our weather is made. Everything from our weather happens from the ground to the troposphere. Above that is the stratosphere. Above that is the mesosphere. Above that is the thermosphere. Our atmosphere blocks out most UV light rays. UV light is very dangerous. How many of you guys have had teachers, parents, grandparents tell you to put on sunblock? Okay, lots of you guys. Why do you need to put on sunblock? Because it protects you from UV rays. UV rays are very dangerous because they cause skin cancer. Again, you cannot see UV light. But our stratosphere blocks out most of the UV light, and that's why we can walk around most days and not get cancer by the time we get to be 4 or 5 years old. So we're going to do a demonstration. I have 3 kids. Stand up for me. Let me introduce you guys to these guys. First of all, what's your name?
My name is Llewellyn.
Llewellyn. Everyone say hi to Llewellyn.
Hi, Llewellyn.
What's your name?
My name is Lillian.
Lillian. Everyone say hi to Lillian.
Hi, Lillian. Layla.
Layla is a pretty name. Everyone say hi to Layla. Hi. They have in their hands what are called UV beads. What color are these? White. I want you guys to tell, or clear. Clear or white. I want you guys to go outside with a teacher, and I want you to report back to me what happens to these when you go in the sunlight. Okay, go ahead. You have what you're going to do. In fact, what I have here is a UV light. So if I put the UV light to this, I moved it. It doesn't move, but I shouldn't have moved that. It doesn't move because there's no heat, but there is UV light. So I'm going to put that and just kind of cover that for right now. Okay, how am I doing? Good? All righty. There's other types of heat now. There's conduction. Conduction is the transfer of heat through direct contact. How many of you guys have ever made macaroni and cheese? How many of you have ever boiled water? When you do that, you are creating heat through a process called conduction. It's through contact. You're putting that pan on a hot oven. The hot oven is touching the bottom of the pan. It's boiling the water. It's cooking the macaroni noodles. That's conduction. That's heat through contact. So electromagnetic was heat through radiation. Ultraviolet light, visible light. Okay, what happened? They turned purple. Here, let's describe this. Now they're clear or white again, right? So tell me what color they became?
They became purple.
Purplish. So what happened was the UV light was reacting, this was reacting to the UV light. So that's why it is important. Good job, everybody. That's why it's important to wear sunblock on hot summer days, because the stratosphere blocks out most infrared light, but not all of it. Let's see if we can see this. Sometimes it's tough to see. But do you see the purple color? It changes right away because we're inside, but you can kind of make out the purple color. That's infrared light. Infrared, again, is really dangerous on hot summer days. So let's do another. I need 4 more people to help me here. Okay. Come on up, you. Let's do a girl. Come on up, you. Let's come over here. Coming up, you in the green. Yeah, come on up. And then, yeah, you, right here. Okay, 4 people. Stand right here. We're going to do a demonstration on conduction, okay? Everybody stand here. Everybody walk toward me. What's your name?
Victoria.
Victoria.
My name is Brian.
Brian.
My name is Trayshawn.
Trajan.
Trayshawn.
Trayshawn.
Yes.
Oh, good.
Solara.
Solara. Okay. Here's what we're going to do. I want you guys, do you see these? You get to go first, so you get to pick your favorite color. Red, purple, blue, or green. And what I want you to do is when you grab it, I want you to face everybody. I want you to cup the bottom. It is glass, so don't drop it, all right? Cup the bottom and then show everybody what's happening. This is demonstrating what conduction is. Does everybody have warm hands? Let me see your hands. Warm? Warm. How are my hands? They're cold, huh? Oh, you guys have great hands. Okay, ready? Go ahead. You start and then turn away, turn toward the group pretty quick. Pick your color. Pick your next color. Go ahead, pick your color and then show everybody. Pick your color and show everybody. So what's happening? If you looked on the table, everything was still. The water was at the bottom. The heat of their hands, and all their hands were really warm. The heat of their hands is boiling the water to the top. That's conduction. That's heat through contact. Electromagnetic heat we cannot see. It's the heat, how we get heat from the sun. This is heat through contact. Does everyone see the difference? Because this is very important to understand the difference when we talk about what makes our weather. Okay, good job, guys. Thank you so much for helping. Now we're going to get away from that for just a second. We're going to talk about high and low pressure, because heat from the sun drives how we get our weather. And that's on cold days or warm days. But there's an important thing to recognize: high and low pressure. First of all, wind moves from high to low pressure. The reason we have wind, if anyone was asked the question, why do we have wind? How is wind created? Wind is created by the difference in pressure in the atmosphere. Wind moves from high to low pressure. If I'm high pressure and you're low pressure, there you are, high to low pressure. Did you feel that? What did it feel like? Wind, right? Wind is hitting you, right? There, let me get your hair. There you are. High to low pressure. That's how wind moves. In a strong storm, it moves really fast, just like this, right? But it can be gentle also. But does everybody understand that wind moves from high to low pressure? Air pressure also has weight. High pressure is heavy. So on a day like today, we have high pressure. So that means we have a lot of sunshine. We're not going to have a lot of clouds. On a day with a lot of low pressure, we may get rain, but if not, we're going to have a lot of low clouds because that air is light. Air pressure is the weight of a column of air above the surface. So high pressure is heavy. Let me give you a demonstration. I need someone to help me here. Right there, yep. Wind is what? What is your shirt? Yeah, wind is what? Wind is 1. Okay. What's your name? Redding. Okay. This is high pressure. Did I get your name right?
Yeah.
Okay.
What did you say?
What did you say?
Bryden.
Bryden. Bryden? Okay. Everyone say hi to Bryden.
Hi, Bryden.
Okay, air has weight. Do you see this is heavy, right? High pressure is heavy and it sinks. This, where my finger is low pressure. So Bryden, I want you to get where I'm standing. Come back here. And I want you to lift straight up. Don't lift towards you. In fact, I'm going to move it towards you, okay? And I want you to lift straight up, okay? Go ahead. Lift. Come on, Bryden. You got it? Straight up. Don't move at an angle. Don't move at an angle. Go straight up. You got this. Straight up. Straight up. You got it. You got it. What's going on? What's going on? Is high pressure heavy? Yeah. So we'll stop for a second. Stop for a second. So the air under this is low pressure. This is heavy. High pressure is heavy. Try it one more time. Yeah, you can't do it because the air is, the pressure is so high, it won't let you lift. Now I'll tell you the trick. What's the trick? The trick was, and the reason I told Bryden, right? The reason I told Bryden to lift straight up, because if you lift at an angle, it lets air in. And once you let air in, it comes up. So, but if you go straight up, you can't, I can't do this. I would lift the table. Hey, good job. I appreciate it. So Bryden demonstrated high pressure. Low pressure is light, which means it lifts really easy. So on a day like today, if we had low pressure, the sun would heat the ground like today, but as it heats the ground, the air heats up and rises now, and now clouds start to form and condense. So rain and storms form because of low pressure and it's lifting. High pressure never lets that happen. Never. We're going to do another demonstration of this, okay? I need 2 people to help me. Let's go in the back this time. Yeah, way in the back there and way in the back there. Come on up. Yeah, yes, come on up. And then, do you want to come up? Yeah. Or, right, okay, sure. Girl. Right there. Yep, blue. Yep. Okay. We are going to demonstrate now heat and low pressure. Can you guys, let me get your name. What's your name?
Caden.
Caden, what's your name?
Emma.
Emma. Everyone say hi. Caden and Emma, right? Okay, Caden and Emma, there is a temperature on this black strip. Can you see it? Tell me what it is. It's in Celsius. Do you see it?
It says 24 and 26.
24, 26? Okay, so 24 to 26 degrees Celsius, all right? Now, what I'm going to do is I'm going to put 2 drops of water. Or how about, let's do 4. Want to do 4? 1, 2, 3, 4. 4 drops of water. Now what I'm going to do is I'm going to heat this up. So what I want you to do is pump it. Okay, you do it to start, and then you go ahead and hold it. You got to use your muscles. So you use all your strength, because what's happening is we're putting air pressure in there and we're heating it up. Okay, so we're going to change out. Let's see if you can. Let's pump it up. You got it? You got it to where you can't go anymore, you think? Got it?
Yeah.
Okay, good. Now I want you to tell me what the temperature. Oh yeah, you guys did a great job. What's the temperature now of that thing, of the strip?
26, 28, and then
28.
yeah.
So it went up about 4 degrees Celsius. It heated up. This is pressure locked now. When I open it, low pressure is going to escape. So what happens with low pressure? What does low pressure do? Lifts and it condenses.
Whoa!
Do you see the cloud? So they created a cloud. Heat, low pressure, and lift. And you have a cloud. And if it were to keep rising, you would have eventually raindrops again. Does everyone understand that? Thank you so much. So, to understand this, I've got 2 drops of rain, right? I put 2 drops of water. 2 drops of water here. If I go like this, and we've done this in one form or another, if I go like this, did I kill the water? No. It just changed phase. All I did was I turned 2 liquid drops of water. Now they are gas. They're invisible gas. So that's the water cycle. It's about water is now around us. Eventually it's going to rise up and it'll fall as rain or snow. And it's back to that phase of being liquid water. Does everybody understand that? Because that's important to understand where we live with rain and flooding. For us, what happens is we don't get like 2 drops of rain. We don't get a little light rain. A lot of times we get flooding. And so the number one thing I want you to be aware of and leave here with is don't play in flooded water. The number one lesson. This happens a lot, right? Have you guys all seen your street look like this at least at one time in your life? Maybe not. Maybe you're kind of young, but for the teachers here, all the teachers here, how many times have you seen a street look like this? All of them. Don't play in flooded water. There's a kid here, 2 kids. I don't know if you can see that there's 2 kids. 2 kids hydroplaning off the back of this truck. One in the back watching. You have a kid taping it all for Instagram, Snapchat, who knows, right? And then you have cars coming in behind. These kids not only are doing that, but they're also in white, so they're the same color as the water. Now, I will tell you, nothing went wrong in this picture. But the person who sent me this picture said, how dumb are those kids who are doing this? Because there are a million things that can go wrong in a picture like this. And I work for the news, and guess what sometimes I have to listen to and hear is about kids who are your age, 4th and 5th grade, who got really hurt because they played in flooded water. So the number one thing I want you to leave with today is don't play in flooded water, because if you haven't seen a street look like this yet, you will. And guess what? Someday you're going to drive like your teachers, like your parents, like your grandparents, and it gets much more dangerous. So just understand how dangerous water is. We were showing it condense, turn into clouds, be 2 drops of water, but it does get dangerous at times. Here is kind of a danger. You're not going to go to the hospital, but in a flood, you know what it is. Okay, so tell me what it is. You tell me what it is. Yep. Good job. This is ants. Ants are like me. Ants hate getting wet. And so during a flood, when the waters go over an anthill, the ants that are not important get lock arms, tentacles, whatever, and they make a base. And they float. And the ones that are a little more important get on top of them. And the little ones that are a little more important get on top of them. And then it just goes up the hierarchy to where the queen ends up on top. And then what else is important to the ants? Babies. The eggs go to the top. But they don't like getting wet. And so if you're playing in flooded water and you come across this and you're not paying attention, you are a dry island. And all of a sudden you're getting hundreds of ant bites, and ant bites hurt. Now again, you're not going to go to the hospital, but you're going to be messing with trying to get them off, and they're going to be all over you. So again, don't play in flooded water. I showed you the first example, which was really dangerous, and this example, which just kind of hurts, right? Thunderstorms. If you hear thunder, get inside right away. The safest place is in your home, school, or car. If there were thunderstorms right now, we're in a great spot, because lightning would hit the school. If it hit the school, it would travel on the outside, it would go to the ground and be out of here. We are as safe can be. We are in a bad place for tornadoes because of the glass. If there was a tornado warning and a tornado was headed this way, we're in a bad spot because of all the glass that would break and head our way. So anyway, good place for thunder, lightning, bad place for tornadoes. So this is an image of what a lightning strike looks like in slow motion. I'll move out of the way so you can see it again. Can you see it now? You good? Okay. Now I can't see. Does it go through? Made it? Okay, here's your connection. Okay, you got it? Okay. How lightning forms. I showed this image already. So we're going to do this again. Sun heats the ground heats up, air lifts from low pressure, clouds condense, the cloud is created. If the air is cold up here, that cloud keeps building up, it gets unstable, and now you have rain, but not only do you have rain, you also now have lightning. Lightning forms because of an imbalance in the atmosphere. So when the atmosphere is balanced and you just have that low pressure lift, it's fine, it just rains. But if the atmosphere becomes like an unbalanced battery, so all of you have seen batteries where there's a plus and a minus, right? But nobody's ever seen a battery that's a plus minus plus, right? That doesn't exist because that battery wouldn't work because it's out of balance. So think of this. I could stand here in front of you guys all day long. I think the cafeteria workers would be mad because I'd be in their way, but I could stand here. I'd get tired, I'd get hungry, but I'm balanced. You could maybe try to push me, but I could resist a little bit, but I'm balanced. But if I lift my leg, I am now out of balance. And eventually what happens? I am going to have to balance, and the way I get balanced is, what did I just do? I put my leg down. Similar to the atmosphere. The atmosphere, the way it balances is it lets its leg down, sort of. It basically lets out an electrical current, and that electrical current balances it. And if it's unstable, you'll get another lightning strike. But the atmosphere is always trying to balance itself when it's out of balance, plus plus. So don't be outside when there's thunderstorms. There's your negative, there's your positive, and there's your lightning strike. Never stand under tall trees. Like ants, I was talking about, don't like getting wet. Most people who get hurt from lightning strikes are under trees because they don't like getting wet. That's the #1 place where lightning hits because they're the tallest thing out there. And you don't even have to be hit by the lightning strike. The ground current goes out. So you might be under the leaves here, and Michael is the trunk of the tree, and I could still get electrocuted by the current hitting the ground. Is it safe in your car? Yes or no? Oops. Yes. Your car is what's called a Faraday cage. Anything metal is what's called a Faraday cage, and you'll learn this in middle school science. It's not your shoes that protect you. So a lot of people think, oh, I can hang out under this tree because I have rubber shoes on. No, it is the metal in your car. So if you're in a car and there's thunderstorms, you're safe. If you get hit by lightning, and I had a friend of mine got their car hit by lightning, it trashed the radio system, by the way, but he was fine. Hit the metal, went outside, went through the tires, and then into the ground. He was safe. It was scary, but he was fine. So you're safe in a school. You're safe at home, in a room. You are safe in a car. You are not safe outside during a thunderstorm. Does everybody get that? Faraday cage, metal. Okay, let's ask some questions here. How far away is lightning? So there's your slow motion lightning. I'll get out of the way for you. When you see lightning and it takes 10 seconds to hear thunder, how far away is that lightning strike? Yes?
I'd say 2 miles.
2 miles. Okay, anyone have a different answer?
A mile?
Yes, a mile?
10.
10 miles. We have a mile. We have 2 miles. We have 10 miles as an answer. Every 5 seconds is 1 mile. The answer is? 2 miles. So here's the thing, 10 seconds is a long time when you think about it. Think of a lightning strike happening right now and it's bright. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, 6, 7, 8, 9, 10, and then you finally hear the thunder. 2 miles is close. So remember, if you see lightning, get inside because it's close. How big is lightning now? Let's talk about width. So if when it hits the ground, how big is it? Yes. What? 36 what? 36 inches. So we're going, what is that? 12, 24, 3 feet?
I think 36 feet.
Okay.
Yeah.
We have 3 feet. We have 36 feet, which is almost the size of this room. Any other guesses? Yes. 36 yards. So 36 is a common number here with this group. Okay, yes.
I think like 6 feet across.
6 feet. So about that. About. Okay, a little bigger in my arm. Okay. 3/4 of an inch. If you could catch lightning, you could catch it in your hand.
I knew it.
Yep, you knew it. It's not very big, but it's incredibly powerful. If lightning is close, why would your hair stand up? You don't have to answer this. I'll show you. Because lightning comes from the sky, but sometimes lightning also comes from the ground. It's called an upward streamer leader. And so what happens is lightning sometimes picks a target. And so you have the electricity coming out of the ground at the same time it's coming out of the sky, and the lightning connection is made up here. It's not made on the ground. So that happens also. So if you're ever outside and your hair stands up, you have to quickly tell yourself, why was I outside when I wasn't supposed to be with a thunderstorm? But then lightning is going to hit pretty close to you within a matter of seconds. So remember, don't be outside. Don't play in flooded water. Don't be outside during thunderstorms. How hot is lightning? What do you think? You got 0 to 50,000 degrees.
60,000.
Today we're 75. The sun is the surface of the sun is 10,000 degrees. There's your lightning strike. It is, you guys got it right, 50,000 degrees. So it's really hot. I'm going to end with this, how I forecast the weather. Here's your rain. The red represents heavy rain. You have lightning also. Those are the white streaks. These are satellite images. It shows clouds. It shows snow and rain. This is radar. This hook is what's called a hook echo. That would be a tornado, a radar indicated tornado. And then there's recording stations that tell me the temperature. There's surface maps and then models. So for school, you are learning what you're learning, which is reading, math, whatever your topics are. For me, I had to go to school and I had to move on and learn the science of basically creating or knowing how to interpret weather models, which would be something how you're looking at the future. And then I also look outside, like on a day like today. If the rock is wet, it's raining. If the rock is swaying, it's windy. If the rock is hot, it's sunny. If the rock is cool, it's overcast. If the rock is white, it's snowing. If the rock is blue, it's cold. If the rock is gone, tornado! So I use both. I use the science, and then I also have to use my eyes. And then I make the graphics. And then how I do my job, I'm in front of a green screen. The weirdest thing for me in front of a green screen is everything's flipped. So when you're in front of the mirror and you're brushing your teeth, and you're brushing your teeth over here, where's the toothbrush? It's over here. On TV, if I were to brush my teeth, my toothbrush would be over here. So the funniest thing, or the thing I really like seeing the most when people come to the TV station and I put them in front of a green screen and say, point out where Umble is. They'll try to point, but remember their fingers over here, so it's really funny to watch them try and figure out where Umble is. But once you figure it out, it's easy, because if you take a selfie, it's the same thing. It's basically you're flipped around, and so you're looking at that. So you know how your shirt is backwards when you point the camera towards you? It's the same way to do the weather. So that's what I do. Do you guys, we have like 2 or 3 minutes left. Who has some weather questions for me? Yes. Come on up, come on up. I think we have time for probably 3 questions. Okay, what's your name?
Romelo.
I'm sorry, Romelo?
Yeah.
Okay, Romelo, everyone say hi to Romelo.
Hey, Romelo.
Okay, what's your question?
Do you see a rhythm when you try to tell the weather?
Do I see a what?
A rhythm.
A rhythm? Do I see a rhythm? Mm-hmm. Oh, explain what you mean by do I see a rhythm?
Like when you're like trying to tell people what the weather is on the weather forecast. Do you like look at, like, do you see stuff that other people can't?
Yes, I think I understand what you're saying with like a rhythm to it. So when you use the word rhythm, what's interesting to me is I'm timed. So when I'm on live, I have to be done, for example, in 2 minutes, 30 seconds. I can go a little bit over or I can go a little short, but I can't be like 4 minutes long. And I can't be like 1:30 because it messes up the show that the producers wrote. So I have to be in a rhythm and that I have to know what's next, and then I have to know where everything is, and I have to have the timing perfect. So in rhythm, in that respect, I do have a rhythm. And then the other respect is I'm trying to tell a story, or what's the essential message I want you to know. So if it's severe weather, I want to make sure you, your parents, your grandparents know to keep you safe or keep them safe. So I make sure that the rhythm is I'm putting everything that's important right at the top, and I'm making sure that it's there, that nothing else after that matters. If that answers your question. All right, thank you. Okay, 2 more questions. Let's do in the middle now. Yes, come on up. Yep. And then we'll go in the back for the last question. Okay, you have to tie your shoes. What's your name?
Kaylee.
Kaylee, everyone say hi to Kaylee. Tell Kaylee to tie her shoes.
Tie your shoes.
All right, okay, no, not now. Okay, what's your question?
My question is, like, why does it mean like the rock, like, why does it mean like when the rock is gone, there's a tornado?
So it's just a joke. So it's just silliness. So, and it's really about how if all I did was the science, I would miss a lot. There's a lot that you see with your eyes or your experiences that goes beyond what you're learning in front of a computer. So that's what that means. So great question. Yes, great question. Last one over there. What's that?
You look very good.
Oh, thank you. Okay. Let's see. Yes, USA. Come on up. Oh, look, he looks like he's on The Price is Right. He's coming on down. He's running. This is great. This is great. Okay, what's your name?
Logan.
Everyone tell Logan to tie his shoe.
Tie your shoes.
But not now. Okay, Logan, what's your question?
My question, you know how when there's like severe weather or
Yes.
like tornado, how do you broadcast it on like every TV?
Because it's so important. So you all heard the question, when there's a tornado, how do you broadcast it on every TV? Because tornadoes are so deadly that if you don't know, in other words, if we were sitting here and there's a tornado coming and we had no idea, we're in an awful place. Because a tornado could come, every one of these windows will shoot out shards of glass. And the wind speeds in even a weak tornado can be 60 to 80 miles an hour, plus trees are coming in and breaking the windows. So basically there's a bunch of bullets flying in here in the shape of glass. So if I'm not telling you guys that there's a tornado on the way, and you guys with your teachers, they've all done these trainings to where when there's a tornado, they know where to put you, they know to get you down, to cover your head. You've done all those tornado drills. So on TV, it's the most important thing to tell you because you need to be in a safe place. Because usually for us, our tornadoes are not going to tear the whole school down. What our tornadoes are going to do is break windows. They're going to break things off the roof. But if you're in a safe place, and basically that safe place is just right there, you're going to be fine. But it's so important for tornadoes that we get on TV, we get on right away, and we tell you, and you're being either notified on your phone or you're being notified on TV, that this is so important. And it's the same thing with hurricanes. So great question. Good job. Yeah, that's great. All right, hey, you guys, thank you so much for having me today. I really appreciate it. So, yeah. Thank you. Yes.
That's bulletproof glass. Does it break it still?
It can break, yeah. Okay, you know, hey, there is a comment. There is a comment. So this is bulletproof glass. So will a tornado break that? Stronger tornadoes will. But what happens is it just hits. And so the point is we're in a bad spot because there is openings. So this is a lot better protection than your window at your house. So the window at your house, you want to make sure you're away. So let's get you back to your house now. If you're at your house, get away from windows. Go in an interior room, like a bathroom. There's no windows in a bathroom, most bathrooms. Innermost room, that'll keep you safe. But if it's strong enough and trees start hitting stuff, eventually it's gonna break. So good comment. That's really important because these are strong. These are strong. Thank you guys for having me out today. I appreciate it.